Hey guys, Mr. Prusky here. Hope you're having a good day so far. We're continuing with chapter 12 today in 12.2. Let's read the name of the lesson. Ready? 1, 2, 3. Surface area of prisms and cylinders. Essential question. Ready? 1, 2, 3. How do I find the surface areas of prisms and cylinders? Okay, so we have a lot of definitions to fill in today. We'll try to make it as, we'll do the best we can here. It's a lot to get through, but it's not that long of a lesson. It's just kind of a long, a lot of definitions. So let's get right into it. A prism is a polyhedron. If you remember, a polyhedron is a three-dimensional shape, a solid that has all polygons. So that's a polyhedron. It's just a shape with all polygons and no curves. That's not like a cylinder or a sphere. But a prism is a polyhedron with two congruent faces. Two congruent what? Two congruent faces called bases that lie in parallel planes. Basically, it's going to be, you're going to have two bases that are parallel to each other. And those are going to be checked. Usually they're not going to be squares or rectangles. Usually they'll be like triangles or pentagons or stuff like that. Usually they'll be the most unique faces on the prism, basically. All right. So a lateral face, parallelograms formed by connecting corresponding vertices. Corresponding what? Corresponding vertices of the bases. That's kind of confusing. Let's just go ahead and call that. Lateral faces are the sides. Okay. Okay, I'm going to draw probably a pretty poor prism here. Do the best we can, but this might actually make it easier with the... Actually, let's go like this. So there is a prism. I don't know if you can see it's kind of three-dimensional. The app just made it a little bit easier to see, but the lateral faces, those are going to be like the sides right here, okay? Whereas the face is going to be this right here, okay? All right, lateral edges are going to be segments. They're going to be what? Segments connecting the corresponding vertices of the bases. So lateral edges are just the sides. So actually, I should have made that more clear with the previous thing. Let's erase this. So the lateral faces, the sides, it's going to be like... That was really bad. It's kind of hard to point to it, but... Can you see how I'm pointing to the side there? Whereas with the lateral edges, I'm pointing at the actual edges, okay? So this whole side right here is a lateral face, okay? But the edge is going to be just this section right here and just this section right here, all right? Okay, surface area is the sum. It is the what? The sum of all the areas of all its faces. So basically, the surface area, I don't know if you guys have heard that term before, but it's basically the outside of the solid. It's kind of like perimeter in three-dimensional space, right? Because the perimeter of this triangle would be this part right here, but the surface area would be all of this space, all the back space, and all that stuff, okay? Lateral areas is some of the areas of all its lateral faces. And it's going to be just the lateral area is just going to be the area of the sides and not the faces, okay? So not the not the front and back basically, or top or bottom. A net is going to be a two-dimensional representation of the faces of the what? The faces of a polyhedron. So if I draw a cube, it's going to be sloppy, but we'll do the best we can here. Okay, so there's a cube. But I don't know if you guys have seen the net of a cube before, but it looks like this. That was bad. Make us... Dang it. Alright. For real this time. Shoot. Okay, I'm going to eyeball it here because we're running out. I don't want to go take too long on this, but I don't know if you guys have seen this shape before. But if you were to flatten out this cube, have you guys seen this shape before? If you were to like unfold this, like take this part and this part, and just let it fall flat, this is what it would look like. This is called a net. Okay, it's basically like it's each of the faces in 2-dimensional shape, even though it's a 3-dimensional shape. Okay, all right. That's kind of. I don't know if you guys have made cubes before in like with what's the word? Origami or anything, but all right. Right prism is each lateral edge is perpendicular. Is what? To both bases. To what? All right. And an oblique prism. Let's say oblique. An oblique prism is a prism with the lateral edges that are not perpendicular. Are what? Not perpendicular, or they are slanted. Okay, I'm going to draw another shape off to the right over here. This is I can't really draw an oblique prism too well, so I'm going to draw an oblique cylinder to show you kind of what I'm talking about. That was bad. Still kind of hard to draw it in this space here. Okay, so that is if this is at a right angle right here, this is the ground. Dang it. I'm just gonna eyeball it. Okay, so this is, I don't know if you guys can see that, but this is like straight up and down. This is up, this is down, okay, and it's just like a slanted, it's like if you took a cylinder and you pushed it, like a pop can, and you pushed on the side of it, it like hit a bunch of discs that made it up, and it kind of just like slanted over a little bit, okay? That's an oblique prism or an oblique cylinder, all right? Okay, so yeah, it's just a slanted cylinder or slanted prism. It's kind of hard to draw a slanted, like, triangular prism, though, so that's why I didn't bother. All right, sounds good. So, surface area of prisms. The surface area of the prism is 2 capital B plus the... I'm going to use a different color. Plus the perimeter times the height, or... We're not going to worry about the second one, but... Okay, so here's what we're going to fill in here. So... capital B equals area of the base. It's not just I'm going to put that in here. It's not the distance, the base distance. Okay, it's the capital B is the area of the base. It's not like the just like base times height in a triangle. Okay, that'll make more sense when we get into an actual problem. And then perimeter, the formula for perimeter, it's N times S, or NS. Let's just put NS. So this is the number of sides, and this is the side length. Okay, sometimes perimeter of different shapes, so you already know those, and you don't need to worry about the number of sides times side length. I think this only applies to regular polygons. That I can't. It's really bothering me how bad I wrote that. That's regular polygons, though. Okay, so basically, what you want to do. Let me explain what's happening here. All right. So here's our right prism. Okay. So we're trying to find the outside of this entire shape. So let's break that down a little bit. Well, we have the 2 bases. We have this space down here. That's part of the area. We have this top one, which is right here. And we also have this side and the front. Okay, so we're trying to find the outside of all of these. And the way we do that is we need to find the area of this base, the area of this top base, and the area of each of the sides. Okay, so yeah, that's all we got to do. And the way you find the area, the perimeter times height is kind of a shortcut. So basically, like what we're doing, if we're looking at just this, let me use a different color here. Looking at just this side right here, well, that's a rectangle. That's going to be, it's going to be this length, or this height times length, or length times width. Actually, let's do length times width. It's going to be, this is width times a length, and then we got to do this front, this front rectangle and this side rectangle. So instead of doing length times width 3 times for 3 different triangles, or the whole entire outside of the triangle, we can just do perimeter times height, because that'll cover each of the rectangles. If we have, this is width, this is width, this is width, we have 3 widths times the height, which is the height for all these are all the same. Okay, so basically it's a shortcut. Instead of finding the area of each of these rectangles, you can just do the perimeter, the top of the base, and multiply by the height, and that'll cover all the rectangles in the different shape here. Hopefully that makes sense. Basically, yeah, if you do each of these lengths times the height, it'll cover the entire that'll cover the area of the middle sections. Okay. But yeah, if you just know the formula, that's totally fine. So let's go ahead and find the surface area of this right prism. So we have, this is a triangular prism, and we have triangles for the bases, like we said. So yeah, so let's go ahead and do this. So we need to find the area of the base. That equals area of the base. Okay, so the base is a triangle, right? So what's the formula for area of a triangle? It's base times height over 2. Oh, this one's kind of wacky. I don't like this one. We'll be okay. We'll be all right. So yeah, let me go back up a little bit here. So base equals area of this triangle with the 6 here. Okay, and the area of a triangle is base times height over 2, right? So we're looking at this triangle. All right, so what's the base of this triangle here? Well, the base is going to be 6. Okay, the height is a little bit trickier. The height is right here at a right angle. Okay. The height, if you actually use Pythagorean theorem, this is going to be 3, this is going to be 6. It's going to be square root of 27. Okay, if you do 3 squared plus 6 squared equals c squared, or no, sorry, I goofed that up. So let me just explain where this comes from. We're not going to get into the details too much because it's not that big of a deal. So this is the height, right? So we're doing 3 squared, which is, we're doing this right triangle right here. Okay, sloppy. 3 squared plus h squared equals 6 squared, because that's the c, right, in Pythagorean theorem. 9 plus h squared equals 36. Subtract 9, we get h squared equals 27. Then you take the square root, you're going to get square root of 27. That's where the square root of 27 comes from. We're probably not going to give you problems that are going to be that tricky where you have to find the height of the base, okay? But for now, I think we're good. So we will just keep that there for now. So it's going to be 6 times square root of 27 all over 2, which is approximately, we got 15.59. Okay. The perimeter P, it's the number of sides times what the side length is, all right? So in a triangle, the perimeter of this base, the perimeters of the base too, I forgot to mention that. Perimeter of the base. Okay, the perimeter of the base, let me erase some of this here. Keep that there. Okay, the perimeter of the base. We need the number of sides in the polygon times the side length, okay? So how many sides does this triangle have? Let's use a different color. Number of sides times side length. Well, it's a triangle, so it's going to be 3 times. And then what's the side length? The side length of the triangle here. What's each of the sides worth? It's worth 6. So we got 3 times 6, which equals 18. All right. And then the last thing we need for this form, we're using this formula up here, right here, okay? The last thing we need is the height of the prism. Okay, now this is a little tricky, not too tricky, but the height of the prism is the distance between the bases. Let me put that over here. Height equals distance between bases. Okay? So capital B is the area of the base. Perimeter is the perimeter of the base, which is this shape right here, right? And then the height is the distance between the bases. Well, how far apart is this base and this back base here? It's going to be 8. It's going to be 8. So now he's got to plug into that formula, so it's going to be surface area equals 2 times the area of the base, which is 15.59, plus 18 was the perimeter, times, let's use parentheses actually, times the height, which is 8. This is going to be approximately, we're going to get about approximately 175.18 square inches. Okay, if you're still a little confused, this is a heavy topic, even if we're like in class, having class and going through this stuff. So just stick to the formula, okay? Stick with this, what I wrote over here on the left, okay? The biggest thing, the area of the base, the perimeter of the base, and the height between the bases, it all really relates to the base, okay? So capital B is the area of the base, capital P is the perimeter of the base, and then the height is the distance between the two bases. If you can find each of those separately, you can just go ahead and just plug it in and simplify it here, okay? All right, let's go ahead and do another one that might be a little bit easier. Let's do checkpoint 1 together here. Oh, we got like no room. This is trash. All right, anyways, do the best we can. All right, find the surface area of a right rectangular prism with a height of 5 feet, length of 11 feet, and width of 4 feet. Okay, I'm going to draw that over here. So I'm going to draw a rectangular prism. That was bad. Okay, this is not going to be perfect, but it'll do. Okay, there's a prism. Okay, the height is 5, which is the distance between the bases. The width is 4, and the length is 11. Okay, so now we're going to plug into the formula. We're going to use the formula. Surface area equals 2 times capital B, which is the area of the base, plus the perimeter of the base times the height between the bases. So let's figure out each of these things here. So area of the base. Well, the base is this section right down here. It's the distance between the bases down here is going to be the rectangle. So how do you find the area of a rectangle? Well, area of a rectangle is just what? Length times width. And what's 4 times 11 going to be? That's just going to be 44. Okay? Now we need capital P is the perimeter of the base. Well, what's the perimeter of a rectangle? You guys remember that formula? It is 2 lengths plus 2 widths. So we can plug in 2 times the length, which is 11, plus 2 times the width, which is 4. Oops, I put W again. So that's going to be 22 plus 8, which equals 30. And then the height is the distance between the bases, which is just 5. Okay? So we're just going to plug all these in. We found the base, the area of the base, the perimeter of the base, and the height between the bases. So now I can just plug these into the formula. So we've got surface area is going to equal 2 times 44 plus, and then 30 was the perimeter, times the height between the bases, which is 5. So surface area is going to be equal to, this should be equal to, it shouldn't be an approximation because we don't do any rounding, 238 square feet. That one was a lot easier than the triangular one here, because the area and perimeter of a rectangle is a lot easier to find. So hopefully that one makes a little bit more sense. Sorry we didn't start with that one, but hopefully you get the idea. All right, a couple more examples. All right, we're doing cylinders now. Cylinders. A cylinder is a solid with congruent circular bases. Congruent what? Circular bases that lie in parallel planes. A right cylinder, the segment joining the center, joining the what? The center of the bases is perpendicular is what? Okay. So, surface area of a right cylinder is this formula. So it's actually the same thing as before. Remember we did surface area equals 2 times the area of the base plus perimeter times height? Well, what is the bases are circles, right? Do you guys remember what the formula was for perimeter of a circle? It's got a different name. What's the perimeter of a circle? Starts with a C. It's circumference, right? Circumference. So that's why it's the same formula except we replace C because the perimeter of a circle is circumference. Okay? So it's still the area of the base, which is a base is a circle, and the circumference of the base, which is also a circle. But the formula is going to be this. We're going to have 2. Now, what is the formula for area of a circle? Area of a circle equals what? Pi r squared, right? And the circumference of a circle equals 2 pi r, right? So now we're going to plug into that formula. So the area of the base is going to be 2 pi r squared plus, so this is that right here is replaced with that b, okay? And then plus circumference, which is 2 pi r, which is the same thing, this goes right here, times the height. So this is the formula you can use for, this is the formula I'd probably use for this one, for surface area of a right cylinder, okay? The same principles as before. We need the area of the 2 bases, we need the area of the sides. And it's the same principles as before, we just have like the special formulas for circles we need to use, all right? Let's do this now. Let's go ahead and find the surface area of this right cylinder. All right. So again, surface area is going to equal 2 pi r squared plus 2 pi r h. All right. So what for this cylinder over here? Do we know the radius? Radius is 4. Do we know the height? The height is 5. So now we're just going to literally just plug it in. Surface area equals 2 pi times radius, which is 4 squared, plus 2 pi times 4, which is the radius, times the height. The height is also the distance between the bases. That's what's over here. All right, now we're just going to simplify that. So surface area is going to be approximately, we got to round with pi here, 100.5 plus 125.7. So surface area is going to be approximately 226.19 meters squared. Okay, so let's just plug it into that formula. It's the same principles as before, but it's just a little bit goofy with circles. Why don't you guys try checkpoint 2? It's the same thing, but now we have a height of 9 centimeters and a radius of 6 centimeters. All right, welcome back. Let's do this one. So again, we're using surface area. Surface area equals 2 pi r squared plus 2 pi r h. This time we know the height equals 9 and the radius equals 6. So surface area equals 2 pi times 6 squared plus 2 pi times 6 times 9. Surface area is going to be approximately, when you multiply those together and add them up, you should get 565.49 centimeters squared. And then also, even though it's a 3-dimensional shape, we do square meters and square centimeters because it's still like square footage in a 3-dimensional shape. Remember way up here when we talked about that net, when we laid this out flat? When you lay out a 3-dimensional shape flat like this, it still covers, like, this is still square feet in 2-dimensional shape, in 2-dimensional space. Okay? All right, almost done here. The last example is a little bit different, but not too bad. Okay? Find the height of the cylinder shown, which has a surface area of 198.8 square millimeters. Okay, this time we actually know the surface area, and we're trying to find the height. So this one's a little bit trickier, okay? So we're going to do, so it also applies to like prisms and stuff too. So we're going to do surface area equals 2 pi r squared plus 2 pi rh. But this time we're going to replace s with 198.8. And we also know the radius is what? Radius is what over here? It's 2.8. Okay, now we gotta do some simplification here. So what I would do is I would try to get h alone. I'd try to get h alone over here, but first thing I would probably do is simplify all the numbers in front of h. So these and these, I would simplify those first. So we're gonna get 198.8 equals, that's when you multiply 2 times pi times 2.8 squared, you're gonna get approximately 49.26 plus, and then 2 pi times 2.8 is gonna be about 17.59 times the height. Okay, so we're looking for the height this time. We're not looking for the actual surface area. We're working backwards. All right, so now we need to solve for, how do we solve for h now? How do we get rid of this 49.26? We're going to subtract. That's going to be 149.54 equals, these are going to cancel, 17.59h. What's the last step to solve for h? We need to divide by 17.59. So h is going to be approximately, once you divide by that, you should get approximately 8.5 millimeters. Okay? So same principles as before, except if you're looking for the radius or the height, we'll probably just have you look for the height if we're doing ones like this. You need to get h alone. You need to move stuff away from h first. So you'll actually be given what the surface area is equal to and need to solve for h. Just like we've done before with, like, you know, when you had like an area of a rectangle was 36 and you knew that the height was 4, or the width was 4, then you would solve for, so if you had, for example, if you had the rectangle, the area equals 36 and the height was 4, well, area equals length times width, so you do 36 equals, length times 4. Oops, that's W. And you would divide by 4, right? Remember doing this a while ago? So it's the same principles as before, except it's with a little bit more complex of a problem. But the same principles apply. Okay, I think that's all of it for today. This is a really hard lesson, so make sure you turn in your homework, ask questions if you have them, and yeah, it's I'm still not sure whether we're going to quiz on this stuff or not. We might just teach it to you and make sure you guys know this stuff, and I'll let you know if we're going to quiz or not. But thank you guys for watching, and make sure you complete your homework, and we will see you soon.